Hi, my name is Luciana Rietti. I'm a senior biology major at Oglethorpe University, and this is my bioseminar long talk presentation. I chose to do caffeine, review caffeine and its effects on the body. So basically, I was very interested in doing this topic because personally, I drink a lot of caffeine during the day, and I was very interested in seeing if that had very positive or negative effects on the body. And I was trying to understand how it works and how it functions when it enters the body. So this is why I chose this presentation. So the outline is going to start. I'll explain a little the basics of what is caffeine and how does it work and how it works in the body. Then I'll go on to show you the experimental study I picked. So I'll explain the hypothesis, the basic major question of the study. I will also explain the methods and tests they use, because they did test for major parameters, which are motor coordination, anxiety, spatial learning, and memory, and sociability. And I'll give you the conclusions of the paper and a big take-home message I got from this presentation, and I think you should too. So, basics. What is caffeine? It's a stimulant. It basically increases activity in your brain and nervous system. It's probably you all know it's found in tea and coffee, energy drinks, and other beverages. I feel like everybody consumes caffeine at least at some point in their day or in their lives. I found this fact very interesting. So it was estimated that 90% of the US population and 80% of the world's population consume caffeine on a daily basis. So just imagine this is a very huge statistic. Imagine just how many beverages have caffeine in them and how much we consume them on a daily basis without even realizing it. And just in coffee and tea that we know, we find it everywhere. So how does caffeine work? Once you drink it or ingest it or whatever, it goes down and it's absorbed by your small intestine. Then it enters the bloodstream, and through the bloodstream, it goes into the brain. So in the brain, adenosine is a very important chemical. It's basically, its job is to make humans feel tired. So it binds to a specific adenosine receptor. And once it binds, that's when your brain tells the body that it's tired and wants to go to bed or wants to go to sleep or wants to be relaxed. So when you drink caffeine, caffeine has the same shape as adenosine. So it can take the place of adenosine and its receptor. And instead of making you feel tired, caffeine blocks that. And caffeine comes in and alters your body. Basically, it makes you feel more alert. It makes you feel more energized. It takes away the tiredness you were supposed to have. So it basically blocks adenosine from attaching to its receptor, and it will make you feel altered. Basically, it triggers your brain activity and the adrenal glands to produce more adrenaline, so you're more hyper. This can last for about 4 to 6 hours, kind of. Once you drink caffeine, the effects of it can last a little longer. So some pros and cons I thought were really important for this paper. As they previously showed in previous studies, that caffeine makes us more alert. It can make you have a jolt of energy, makes you feel more alert and awake. And it's also shown to improve response time and accuracy. It also has been shown to put us in a better mood. So it can perk up your mood and flood you with positive feelings and happy thoughts. And it has also been shown that it may improve your memory. it has been shown to improve like long-term memory, and like other studies have shown that moderate caffeine consumption reduces the risk of developing dementia and Alzheimer's, which is very huge. Some cons, they obviously, as I explained before, they block adenosine from attaching to its receptor. So instead of making you feel tired, it makes you more alert. So that disrupts your normal sleeping patterns. That can make you not want to go to sleep, and your brain is still working and functioning instead of cooling down and going to sleep. So that causes insomnia. It has also been said that the increased production of stress hormones is caused by caffeine. So our adrenal glands produce more of the stress hormones that are like norepinephrine, adrenaline, cortisol. And this is not very good because like cortisol release contributes to both fatigue and insomnia. So it's not a good outcome from drinking caffeine. And the last one, heart health. It has been found, they have found like a link between the use of caffeine and inflammation. It says that when you combine caffeine, when you drink caffeine, it's supposed to like raise your blood pressure. That's why sometimes you feel like your heart is beating very fast, or like you feel like you're anxious, just because it can raise your blood pressure. So the experimental study I've chose, the title of it is Acute Administration of Caffeine, the Effect on Motor Coordination, Higher Brain Cognitive Function, and the Social Behavior of BLC 57 Mice. So the big thing they're looking at this in this research is they're measuring the effect of caffeine on learning, memory, anxiety, and social behavior in mice. They have hypothesized that administering moderate doses of caffeine increases the higher brain functions and locomotion of mice. Caffeine-treated mice will display anxiogenic behavior, which is anxiety-like behavior, and a decrease in social parameters. So for our methods, they had 3 different groups of mice. They were all male. They had the control group, which received no dose of caffeine at all. Then we had the moderate dose of caffeine, which they had a little caffeine. And the high dose group, which had a very high dose of caffeine in their body. Then the animals were tested after 7 days of caffeine administration. And the first test the study showed was the Rotor-Rot test, which assesses coordination and balance in mice. So you can see it's like a cylinder structure, and it like goes around. It's a cylinder that rotates basically. It goes at around like 45 revolutions per minute. So the basics of this test is that they place the mice on the rotating cylinder, and they time how long it takes them to fall. So the longer the mice stay in the rotating cylinder, the higher their balance and coordination they have. The second test they did was the Elevated plus Mace test, which examines anxious behavior in mice. As you can see, it consists of 4, like it's like a cross basically. 2 of them were like open arms. They had no edges, like if the mice could fall right there. And then they had 2 closed off arms, which had very high walls. This test consisted of placing the mice in the middle and recording their number of entries into the closed off arms and the time they spent in the open arms. So basically, the more they went into the closed off arms, the more anxiety-like behavior they showed, because they didn't prefer an open space. which that normally gives them more anxiety. So they prefer to go to closed off spaces in which they feel more safe. Yeah, so the more time they spent in the open arms, the less anxious they were, and the more time they spent in the closed arms is the more anxious behavior they show. So the third test they did was the Morris Water Mace test, which assesses spatial learning and memory. So you can see it's like a circle pool in which they place some water and they place the mice in a specific spot every single time. And they have to find the platform. So they swim toward the platform. Researchers basically record the time it takes them to find the platform, the distance they swim in order to find the platform, and the velocity they swim at. So the more they did different trials, and after a few trials, obviously the time and distance should have decreased, but they compare the results of the moderate, the control, and the high dose of caffeine group and see which one had more memory and spatial learning and faster. The last test they did was the 3-chamber social apparatus test for sociability and preference for social novelty. This test is, I feel like, the most complicated out of the 4 of them, but basically they place a mice in the middle chamber for 5 minutes. And after the 5 minutes pass, they start with session 1, which is basically placing an unfamiliar mice, and they had no prior contact with the subject mouse inside the wire cage in one of the side chambers. The subject mouse was then allowed to explore the entire apparatus freely, and the researchers recorded the time spent in each chamber, as well as number of chamber entries, and the time spent with the unfamiliar mice was recorded. And then after that, session 2 began, in which they placed a second unfamiliar mouse in the wire cage inside the chamber, which was empty during session 1. The test mouse is then left freely to choose between chamber containing the already investigated mouse, which is the old stranger mouse, and then the one containing the unfamiliar mouse, the newer unfamiliar mouse. And that's how the preference for social novelty is measured in session 2. It's indicated by spending more time in the chamber containing the novel mouse than the one containing the already investigated mouse. Okay, so for results, figure 1 shows the different groups. We had the control, the moderate dose, and the high dose of caffeine. And in the y-axis, they had the latency to fall in seconds. So if you remember, it was the rotor test, the one with the cylinder where they placed the mouse in a spinning cylinder, and they recorded how long it took them for them to fall off the cylinder. So the longer the time they spent hanged on to the cylinder, the more balance and coordination they had. And as you can see, the moderate dose group was very high. They had that very high coordination and balance. They outperformed the other groups. So this showed how caffeine does improve coordination and balance when you take it at moderate doses. Then in this figure, this was the elevated plus Mace test that assesses anxiety. As you can see in figure 3A, which is the top one, you can see that the control was higher. They had more entries to the open arms, so that kind of showed that they had less anxious behavior compared to the other ones. They were not afraid of being in the open arms. They had no fear So they preferred being in the open arms instead of the enclosed off arms, which the moderate and high dose groups prefer because they feel more safe and less anxious. Yeah. And then B shows the time they spent. So you can see there's a big increase. The control group had a very long time. They spent a very long time in the open arms. So that shows that they had zero anxiety. They showed no anxiety compared to the other moderate and high dose of caffeine. Then this is the Moore's water mace test, which was used to test cognitive function, which is the pool where they swam to the platform. So you can see in figure 2A, it shows on the x-axis, it shows the trials they did. So they basically did 8 trials for all the mice. And on the y-axis, they recorded the time it took them for to reach the platform. And as you can see, like it kind of goes down as you have more trials. That kind of shows how the mice started learning the path to the platform and having good memory. And if you look closely, the moderate dose, which are the very black dots, it's circled black dots, show how they had the less time to reach the platform once the 8 trials passed. Like they always were the fastest to find the platform. They remember where it was and they remembered how to get to it. So they were quick and easy to memorize the path to the platform. They also, in figure 2B, it shows the distance it took them to reach the platform. It's kind of the same as in figure 2A. It goes down as you have more trials. They swam less distance as they reached the 8 trial. And you can see also that the moderate dose also always had the lower distance swam. So it kind of shows how they were learning very quickly where the platform was and they were memorizing it. So that shows a very high cognitive functions of spatial learning and memory. Then lastly, figure 4 was the 3-chamber test to assess sociability and preference for social novelty. So as you can see in figure 4A, they record the time the control spent with the mouse and the time without the mouse. So as you can see, the control spent the most amount of time with the mouse out of all of the 3. So kind of shows how the control had a little increase of sociability compared to the other 2. Then in figure 4B, it shows the control as well, the moderate dose and the high dose. You can see how the control also spent way more time with the new mouse rather than the old mice. So it kind of showed how their preference for social novelty increased as well. They preferred new mice. They were not scared of approaching it. So caffeine-treated mice showed a decrease in sociability and preference for social novelty. The control was always higher in both of these in sociability and preference for social novelty. So the conclusion for this paper, the moderate dose, it showed like when you take caffeine at moderate doses, it enhances memory, motor coordination. The only thing is that it increased anxious behavior because like all of the caffeine treated mice showed more anxious behavior than the ones that were not treated with caffeine. And they also showed a decrease in sociability and preference for social novelty. But other than that, they did very good in all the balance, coordination, spatial memory, spatial learning and memory, motor coordination, everything like that. Everything physically, they did really well. Then the high dose was they deteriorate motor and cognitive functions. It also increased anxious behavior and decreased sociability and social novelty. They showed how kind of like caffeine at very high doses is not good for health physically at all. And the last thing, kind of the effects of caffeine on like motor function and memory are really like dose dependent. The more caffeine you intake, the more deteriorated it will be. So you have to like control, basically. You have to have a moderate dose in order to show good results, because if you drink too much of it, you won't get good results. And if you don't intake any caffeine, you won't have good results as well. But the sociability and social novelty is not dose dependent, or the anxiety-like behavior is not dose dependent at all. So should we take caffeine or not? This is the big like take-home message. Should people drink caffeine or should they avoid it? As I mentioned before, just control your intake. You have to moderate your intake of caffeine daily, because if you drink in moderate doses, it's very good for your body, puts you in a good mood. It can make you feel more energetic. So just moderate your dose of caffeine intake daily. A normal amount would be like 100 to 200 milligrams per day. So that equals like 1 cup of coffee is equal to 95 milligrams. So you can have like 2 cups of coffee a day. So yeah, caffeine is good for your body. Just don't take it at high amounts. And yeah, thank you very much.